now come up the objectives of your study. So that's basically what we looked at in the beginning of the year. We're looking at, we're putting a lot of effort to try to help ourselves to come up with a good study background and a good statement of the problem or a statement of opportunity and the objectives. So that's where we put a lot of our focus in that section of your proposal. That's chapter 1 or section 1. Again, we moved to section 2 of your proposal, which is your chapter 2, the literature review. How will you be able to review literature for your study? Of course, we also appreciate the fact that there are different approaches to literature review, but specifically what we looked at was systematic literature review. And we had sessions on that for almost the whole month. And how do you do systematic literature review? A publishable paper could easily be, drawn from your efforts in literature review if you follow a systematic literature review. So we did that. And recently, in the last 2-3 months, we have focused attention on your chapter 3 or section 3 of your proposal. And basically, we began by looking at methodology versus methods. We looked at this several times, and we also looked at your philosophical paradigm. Where do you belong? And we, of course, from the clips we looked at, there was an indication that we have more than 3 research paradigms, but the core are 3 that we looked at. That is the positivists. We looked at the realists, the integralists and the pragmatists. We looked at those in details. And after that, if I remember properly, we also looked at research designs and research approaches. And at some point, we also looked at data and data collection instruments. How do I come up with a good data collection instrument? And here, in fact, we went as far as looking at even the pilot studies. How do I conduct a pilot study and come up with the preliminary results on my study? And maybe we also looked at, I think I remember clearly, we also looked at the reliability and validity of your research instrument. So if you may notice, you find that we have been critically trying to follow your research proposal, and those are basically the first 3 sections or chapters. Even today, we want to continue looking at the same, but specifically today, we think that we want now to go and try to look at data. Okay, because now you have your research instrument. You have verified its reliability and validity. And now you've gone to the field there, you've collected the data. And now what do you do with this data? You need to prepare this data and get it ready for analysis. Okay, and so that's what we think we want to try to do today. And in this session this morning, we basically want to look at the basics of data analysis and the statistics. Now, I also want to say here that there are several research analysis tools or softwares that people use. Many people nowadays use other software, others use Sept, others use eViews, others use Python. There are many. But also over time, I've noticed that many people are familiar with SPSS. So that's why I thought today, as we remind ourselves on some few basics of data analysis and statistics, I thought that we could maybe start with the known as we move to the unknown. And so if this is something that you're very familiar with, you're very welcome to the, at that point when we are doing some discussion after watching the clip that we have today, you're very welcome to provide more information, provide knowledge on this. But I want to now invite us to watch a small clip on the same. And I don't know why they show it's the way this system behaves that way. Okay. So I would like to again say that for those who are very familiar with SPSS, we are not really wasting your time. What we are saying is that we are inviting you after this to give us more insights and more knowledge on this. And for some of you who may be like me, who have very little or no knowledge on some of these things, I also invite you to learn a few things today. Sometimes you can say that with this one, I'm not bothered. Someone will run for me the research. Yeah, that is okay. Someone can run for you the research. But remember, when you're presenting results and when you're defending your book, that someone will not be there. It will be you. So it's good that you have some basics so that you are able, even the person who run for you, that if at all that's what you're planning, should be able to explain to you what happened, and you should be able to grasp some of these things if you have prior information on how things happen. So so this is what we'll be looking at. We'll be looking at basically four things. The one is we want to understand data types. I want to look at the basics of statistics, and they will also look at descriptive statistics versus differential statistics, and we'll conclude with collection and regression. And so let's go just to the clip that we have for today, and then we watch, and then later we shall come back and discuss a few things before we move to the next session. So welcome with me to this clip video.
So we have to start with our today's lecture. This is basically on SPSS. I am going to teach you how you can use SPSS software for your data analysis, especially for those who...
Maybe just to confirm if this is the sound is there and it's clear from your side. Hello?
It's clear.
Okay.
You can hear.
Thank you.
So we have to start with our today's lecture. This is basically on SPSS. I am going to teach you how you can use SPSS software for your data analysis, especially for those who are new to this data analysis. Okay, let's start today's lecture. So we are going to learn in this lecture very briefly about some data analysis techniques.
I think I've had some problem of I don't know what it is. My thing just closed suddenly. I don't have like the issue of network. Let me try to restart it again. I guess it's the issue of network. Let me just bear with me. Okay.
On SPSS. I am going to teach you how you can use SPSS software for your data analysis, especially for those who are new to this data analysis. Okay, let's start today's lecture. So we are going to learn in this lecture very briefly about some data analysis techniques, what is the data and how we can manage the data in any software. It's irrespective of SPSS. SPSS is just a tool to analyze the data, but we have different types of the tools available. SPSS is one of them. At the end of this lecture, I will give you one tip. That tip is very special, and all those who are doing research, all those who are doing data analysis, they are having some challenges, difficulties on the data analysis. I will give you one tip how to interpret and how to get your result quickly. So you can use that tip anywhere or all type of test or all type of data analysis. That will be better for you in order to understand what is happening there. Okay, now let's start with the first thing. We need to understand the data. The second one would be introduction to this SPSS software. The next step would be we need to understand the SPSS environment, how we can do the data entry, how we can import our Excel sheets, how we can work with the SPSS software. That would be next point. And finally, we will do some descriptive analysis and correlation and regression. That is part of your syllabus. So this would be the learning outcome for today's lecture. But let's start and let's try to learn step by step. So in that case, you can be in a condition to understand the concept very clearly. Okay, now let's move on. So first thing we need to understand is basically what is your data analysis. And if you remember in the last class, I already explained about the different forms of the scales. And at that time I was talking about we have to learn which scale and what type of data would be available and what type of analysis we can do on each type of the data or each type of the scale. Okay, so scales are very important in this regard, and also we need to understand that the scales can be used to collect data, but also we have to understand each scale have some limitation in the data analysis. We cannot deal every scale like similar, so we have to do some pre-work and we have to understand what are the limitations on each scale and how we can improve or how we can use these scales in our research. Okay, so this is the basic concept. Now let's start with the previous class, a class before the last class. If you remember, I told you about the 4 different types of the data. Now, these are the types of the scales also. So we understand that the first scale is nominal. Do you remember what is nominal scale? Any confusion on this? Everybody is clear on the nominal scale. Nominal scales are those scale where we use different types of the categorization labels to identify the different groups of your sample or your population. Okay, so this is called nominal scale. For example, color, for example, different age groups. So all these different types of the scales are different types of the groups are basically nominal. Male, female, okay, classes, semesters, all these are basically nominal scales. Okay, now in the nominal scale, because it is just simple categorization of group, so we have very limited options in terms of doing statistical analysis. If you remember, I mentioned that on the nominal scale we can only do frequency distribution. You remember, we can only do frequency distribution. Remember this, nominal scale, you cannot take mean, you cannot run all the descriptive statistics, because it is the nominal scale and it is categorized with respect to the different groups, labels or tags. So that is why we cannot do means or medians or mode. We just do simple frequency distribution. Okay, then I mentioned the ordinal scale. If you remember, the ordinal scale is the scale where I mentioned that the data is followed by an order, mean that there is a rank between the options available for the user. So the data we receive from the ordinal scale will be in the ranking. Okay, so this rank scale or this ordinal scale, we have some limitations. We can use descriptive or we can use some statistics, but very limited inferential statistics are possible. I am using these two words, descriptive statistics and inferential statistics. I'm going to explain these two terms in a while, so don't worry about that. I will explain each and every step in detail for here. So the next scale was interval, and then we have ratio scale. So we are using interval scale in terms of rating scale, and also we are using Likert scale in terms of interval scale. So you are using rating or you are using interval scale, Likert scale in the under the interval scale. So that is how we have different types of our data, and this is what I explained in detail in the previous lecture. So you can get that lecture and you can understand that this is very simple in order to understand these different types of the data. Why I'm telling you this now? Because this is what we need to use in the SPSS. So please make sure when I explain everything, it is clear to you. Okay, if you have any question, you can post in the comment and I will try to answer your question instantly. Okay, so here I would take a little break and I request you to post your answer if all these scales are very clear to you and you are using it in your research. Okay, so just waiting for your reply. Please mark your answers. And my dear students, one thing we should remember, today I'm not in the mood of listening that particular answer you always give me. If I ask you anything, if you have any question, you should ask. Don't tell me everything is clear. Okay, so let's move on. Now we are clear about these scales. Let's move to the next step. The next step is trying to understand statistics. Okay, now if you try to understand the statistics, there are two major categories of statistics. We call it, one is basically descriptive statistics and other is called inferential statistics. Okay, now what is descriptive statistics? Now, descriptive statistics is very simple. We are trying to present the data, organize it, or summarize it, the information. Okay, so means that we are presenting data, we are trying to organize, we are trying to develop some charts or some graphs based on the frequency distribution, mean, mode, median, but not much analysis is being done. So what we are doing, we are just taking data and presenting the numbers. Okay, this is the number of male, this is the number of female, this is the number of employed, self-employed, private or government. So we are just taking the data and representing it and organizing it in a format in which we can understand the numbers very effectively or very clearly. Okay, now remember, descriptive statistic does not deal with the hypothesis testing or any other inferential analysis. It just deals with the frequency distribution, mean, mode, median, variation, and all this. I will explain it later on. Okay, now the second type of the statistics is called inferential statistics. Okay, now inferential statistics is interesting. It is basically your hypothesis testing is included in the inferential statistics. Basically, inferential statistics take sample, do the analysis, and try to predict the future or try to predict the prediction for whole population. Okay, so in simple word, drawing conclusion about a population based on the sample we collected. Okay, so inferential statistics is different than the descriptive statistics. In the inferential statistics, we do decisions, we do predictions, we do forecasting. We are trying to analyze the behavior of a population based on the sample we draw from, a limited sample we draw from the population. So this is called inferential statistics. Okay, clear? So descriptive is just the presentation of data, and inferential, it is based on the decision making. We are trying to estimate, we are trying to predict, or we are trying to explore, or we are trying to write about the future. Okay, now let's move on to the next point. Now the descriptive statistics. What is the descriptive statistics and how it help us in our research, and what are the different forms of the descriptive statistics? Let me show you what are the different forms. The first thing is frequency distribution. When your scales are nominal, what you can do is you can just tell them, okay, how many specific group, how many, for example, if we are using male and female, so how many male, how many female. So we can say that, okay, 30% female and 70% male available in my sample size. So this is just a description, or it is just a detail of our data or our sample which we collected, and we are just trying to give the frequency distribution, okay, based on the number of available option in one group. Okay, now the second one is central tendency. So in descriptive statistics, either you can do frequency distribution or you can do central tendency. Measures of central tendency, there are three. These are mean, mode, or median. I think everybody knows about these three numbers or three names. Mean is basically an average, so we can take an average. Mode is the most frequent number, the number which is most repeated in your data. Okay, for example, if you selected 1, 2, 3, 4, 5 is your Likert scale, and the mostly people they replied you 4. The 4 would be the mode. Okay, so the mode is the more frequent number, the most frequent value or frequent number in your data is called mode. Okay, clear? And then the median. The median is simple. Median is basically the middle value of your data. Okay, so if we divide your data into two values, 50% and 50%, the middle value would be called as a median. Okay, so these all are called measurements of central tendency. Okay, is it clear? Okay, if it is clear, let's move on. The next one, okay, I'm not going into the details of how we can measure it because we are going to use the softwares to measure it, but you have to understand what are these values. Okay, now the third part is dispersion. We can measure dispersion based on our descriptive statistics, and dispersion have three different values. Okay, you can use standard deviation. Standard deviation is simply, if I explain it in a very simple word, if you have a mean value of 5, so how much other values are separated from the mean value is called standard deviation. For example, the next value is 5.5. So 5 is your mean and 5.5 is the next value. So 0.5 is your standard deviation. Okay. So we are trying to assess whether your data is scattered or they are very near to the mean. Remember, we always prefer the data which is normally distributed or mainly concentrated around the central tendency. That is why we have to measure the standard deviation. If your data is too much scattered, it is difficult for us to measure, to do the inferences. Okay, so we need to have a bell shape or normalized data, normal distribution. That I will explain in future if I find time on this. But for now, you should understand this measures of central tendency and then dispersion. Dispersion is basically the variance. So we have standard deviation, how much your data is scattered around your mean, and then we have variation or variance. Variance is basically how much your data is vary, means that it have different values. Okay, so how much is the difference between the each value is called variance. Okay, so means that average variation means that one value and the second value, how much they are different from each other. Okay, and the range is basically the length of the data. For example, in your Likert scale, if you use 1 to 5 scales and your respondent, they give only option, nobody choose option 1, means 1. So 1 is not available in your data, but the people they choose 2 and some people they choose 5. So 5 minus 2, 3 would be your range. Okay, so the range is the data, the consistency of the data means that the lowest value and the maximum value. So the difference between the maximum and the minimum value is called your range. So we can see that how much is the range of our data. That is also an important measure of dispersion. Okay, so dispersion is scatteredness, how much your data is scattered from the mean. So in the descriptive statistics, we can do very simple thing: frequency distribution, measures of central tendency, and dispersion. Okay, please remember these names because we are going to calculate these all today and we are going to see how we can interpret them. Okay, now remember, I am not going to give you any information on how we can write the interpretation. I will explain, and from my explanation you have to write by yourself. Okay, I will explain everything and you have to write it for you and for your examination also. So make sure you have done with this standard deviation, variation, and the range. I think all of you are clear on this. So can we move on? So can we clear this descriptive statistics? Everybody is clear on these 3 points: frequency distribution, central tendency, and dispersion. Frequency distribution is just simple measurement of your frequencies or the number of particular group in your sample. And then we have central tendency, which is mean, mode, median. And then we have dispersion. Dispersion is basically standard deviation, variation, and range. Okay, so I hope so everybody is okay with this. Okay, any question here? If you have any question, you can write in the comment box so I can reply to your answer, your question. Okay, if this point is clear, let's move on to the next point. The next point is understanding the inferential statistics. That is the main point where we have to do all the analysis. We have to do the decision making, okay? Now, inferential statistics is huge. There are so many tests, so many different inferential statistics are available, parametric, non-parametric, a lot of inferential statistics is available. Okay, now the point is, according to your research, I will give you very brief introduction of inferential statistics, and I will tell you a few tests which are very important for you in order to do your final year project or do your research article or research paper. So if you are not a statistician, don't worry about this. I will explain everything and we can do it together easily, no problem with that. Okay, so make sure you are clear about the inferential statistics. Now, inferential statistics, why we do? Because we need to make inferences, we need to make predictions, we need to hypothesis testing, and we need to determine the relationship between the variables. So all these are main purposes of inferential statistics. So you can see that all the analysis which we do is here. Frequency distribution or descriptive is just a representation of data. It is important, but not important like inferential statistics. Without inferential statistics, you are not able to predict for your whole population from your sample. Okay? So that is why inferential statistics is very important. Let's move to the next point, hypothesis testing. So what is hypothesis testing, which we are trying to do on today's lecture with the help of SPSS software? So what is hypothesis testing? Now, if you remember, I asked you to develop hypothesis, and everybody have their own hypothesis according to their research. So that is your hypothesis. Now, this is a statement. Hypothesis is a statement. I mentioned this so many times. Hypothesis is a statement that can be tested on true or false basis. Okay, so we have to mention whether our hypothesis is true or false based on the evidence we collected in the form of data. Okay, so we do some inferential statistics and then we reject our hypothesis or null hypothesis. But here you have to remember one very important point. Each test, because we have a lot of statistical tests, okay, so each test have a null hypothesis. Okay, remember this point. Each test have a null hypothesis, so we can't change that null hypothesis. We have to learn what to do with this statistical analysis. We cannot shape our own hypothesis based on our own requirement. Yes, we can analyze and what type of hypothesis is required, but if we are talking about the statistical test, the hypotheses are already established. So you cannot change much of this wording of this hypothesis or much of this chronological explanation of these hypotheses. Okay, so you have to understand, because that is what I told you in your hypothesis. I told you you can develop your hypothesis based on a few statements. For example, there is a positive relationship between A and B. There is a negative relationship between A and B. There is a relationship between A and B. Okay, there is a difference between A and B. So all these are different types of the hypothesis which we need to understand. They are directly coming from some test, okay, some statistical procedure. So that is why we have to understand which type of the statistical test is applicable to our hypothesis. This is very important. Which type of inferential statistics is okay or is required to test my hypothesis. Okay, so you have to clear that part. Okay, now let's move to the next point. As I mentioned, each statistical test have its own hypothesis. I will explain while we are doing these hypothesis testing. But remember, each hypothesis have its own statement. And what we are trying to do, this is called a null hypothesis. Every test have its own null hypothesis. So what we are trying to do is we are trying to reject the null hypothesis and accept the alternative hypothesis. Don't worry about the wording. Alternative hypotheses are those which you have crafted during your research. So you have already developed the research hypothesis. Those research hypotheses are also named as alternative hypothesis. How we are going to test it, I will explain. But here, I think we should be clear about the hypothesis testing. Now, the next question will come into my mind, okay, how I can accept or reject any hypothesis? Now, here comes some very important statistical procedures. I choose only 2 statistical procedures for today's class, and the later we will explain. If it is required, we can do another round in any other day. But here I am just talking about the correlations and regressions, okay? Now, correlations and regressions. What are the correlations? So correlations are the statistical tests which gives us the strength of relationship between 2 variables, okay? Remember, it always have 2 variables and the value varies from -1 to +1, okay? Remember, in correlation, we have only 2 variables. There is no independent, there is no dependent variable in correlation. Remember, independent and dependent is just in the regression. So if you have independent and dependent variable, you cannot run correlations, okay? You cannot decide your relationship based on the correlation. Yes, we do correlation analysis, but just to test the nature of relationship. But we cannot conclude or we cannot accept or reject our hypothesis based on the correlations if your variables are dependent and independent, okay? Remember, correlation is not able to test the causal relationship. Please make sure you understand this point. Okay, the values of correlation, they are from -1 to +1. Very simple. -1 to +1. Okay. Now, -1 to +1 means that -1 is strongly negative correlations. When we say negative correlations, it means that one value is increasing while the other value is decreasing, okay? Is it clear? So one value is increasing and other value is decreasing. I will show you in the graphical form also, but remember, I mentioned 2-3 very important things about the correlation. First, it measures the strength of relationship. Second, it only involves 2 variables. Third, it do not have any dependent or independent variables. Remember, it do not have any dependent and independent variables. Okay, let's move on. Let's see. This is the examples of correlations. Okay, if I scattered your data, if I plot your data and I check this, so you can see that there is a trend. If I mention this one, this value, if you can see that this line is straight, it means that this value is X and this value is Y. Okay, so if I write it here, so this one is X and this one is Y, right? So if I explain the value of X from, for example, here I have 0 to 5, okay? And here also we have 0 to 5, for example. For example, I'm just giving you an example, okay? Now, if I draw here is 1, here is 1. So if you can see this one. So the value of X, when the value of X is 1, the value of Y is also 1. So let's see here. There is a slight improvement, right? Increase. So here also increase. So let me just mention this one 2 and 2. So you can see that the value of x is 2 and same with the value of y is also 2, and you can see that all these are increasing trend. Increasing mean when I say value of x is increasing from here to here, the value of y is also increasing. Okay, clear? So this is called a positive correlation. Clear? Anything, any point here, any question? Okay, clear? Any question? Okay, let's try to see this value now. If I write here again x and y, and you can see that x is maximum means 5 when y was 1. Okay, and if you see when y is maximum, x is 1. So you can see that with the increase in value of x, the value of y is decreasing. Okay, the value of y is decreasing. So when x was 1, y was 5. When x is 5, y was 1. This is called a negative relationship. So this is an example of perfect positive correlation, which would be +1. R would be, we call it correlation coefficient, which is R. So R is equal to 1 here. Okay. Now, but here is R equal to -1 because it's perfectly negative correlation. Okay. Now this is -1, and here if you see for all values of x, the y is same. There is no change in the value of y, so here r would be equal to 0. Okay, so now here I understand there are three possibilities: negative, positive and 0. If the negative, it means that there is a negative correlation. The value of one variable is increasing and the value of second variable is decreasing. Okay, and in other case, value of one variable is increasing and the value of other variable is also increasing. This is positive, and otherwise it is negative. And if there is no relationship, the r is 0. So this is simple correlation, and what we call correlation coefficient is r. So r can have positive, negative or 0. Okay, so these three values are possible and we can explain each of them. Positive means that both variables are increasing. Negative means that both variables are, one variable is increasing, so the other variable is decreasing. There is a negative relationship. And in this r equal to 0 means that there is no relationship. Okay, clear? Okay, let's move to the next point. I think here you are clear about the R, correlation coefficient, but here I'm going to explain you one important thing. XY is equal to YX. This is important. This is where correlation is different than the regression. It means that if I say x to y or y to x, the values of r should be same. There is no problem, okay, because there is no dependent or there is no independent. Both variables behave in the same way, okay. So if you write x and y later, So if you keep x independent, y dependent, no difference between these two. Okay, so x, y, the correlation between x and y, where I put x first and y later on, will be equal to yx, where I put y first and x later. Okay, so this is also a simple parameter. Okay, so you can understand. Okay, clear? So can I consider everybody is aware of this correlation now? Okay, can I have your reply on this? Is it clear? Can we move on? Okay, yes, very good question. Can you give example of hypothesis statement to explain the correlation? Okay. Remember, when we say there is a relationship between A and B, okay, there is a relationship between A and B. For example, digital marketing and sales. So when we say this statement, it can be a correlation. If and only if, remember, if and only if the sales and digital marketing, there is no dependent or there is no independent. Okay, so in this case, both variables, they work together. Okay, that is why it is called correlation. So I'm not talking about the dependent, I'm not talking about the cause and effect. I'm just talking about the relationship between variable A and variable B. Okay, but in most of the cases in our research, the variable's nature is dependent and independent because we follow the causal relationship. I will explain in next point, but in simple word, correlation is simply the relationship between two variables. So is there any relationship between digital marketing and sales? This would be correlation hypothesis. Okay, but remember one thing, don't confuse yourself with this statement, because we are looking at digital marketing as independent in our research and sales as a dependent variable. That is why correlation is not efficient, because I cannot say in this statement, if I say the correlation, the digital marketing, and there is a relationship between digital marketing and sales. It means that when the sales increase, digital marketing increases. When the digital marketing increases, the sales should be increased. So you should be clarify on your relationship. Here it is a problem. We can say that when digital marketing increases, the sales increase. I agree with this statement. But when I say when the sales increases, digital marketing increases, this is something we are not clear about. I don't think so that is the case. In that case, this property, if you remember, this property is not holding. Okay, so means that sales and digital marketing and sales, so both are not same. So that is why we use regression, because this is a problem. Okay. Okay, clear? Yes, the positive value of the graph, it is like this, increasing, and the negative value is decreasing. Okay, clear? Okay, so is this clear about the correlation? What is the hypothesis for correlation? The correlation is basically just simple relationship between two values. Okay, if for example, I want to see is there any correlation between the death rate and sales, or sorry, ice cream sales, for example, anything, death rate or and COVID. Okay, so we should understand whether our relationship is causal in nature or it is two-way. Okay, when the relationship is two-way, we can use correlation, but when the relationship is one-way, we call it causal relationship. In that case, correlation is not significant or not sufficient to reply or answer. You reply your question. Okay, clear? So correlation is just a relationship between A and B. Okay. The correlation can be a very good example in a love story. Okay, a person A loves person B and person B loves person A. So both, no matter if we keep person A or person B, so both are loving. So in that case, it can be an example of correlation. Let's move on to the next point, regression. Now this is important. We need to understand where the correlation have some limitations. Do you understand? Correlation have some limitation, but it will not give you cause and effect. Now when we say digital marketing has an influence on sales, digital marketing has an impact on sales, digital marketing has a positive effect on sales. Now I'm using this word effect, influence, impact. Okay, remember these words are different. This word shows a causal relationship, not two-way relationship. Remember, digital marketing has a positive impact on sales. Digital marketing has a positive relationship with the sales. When we say relationship, it's a simple relationship and it can be two-way, but we are just explaining one side of the relationship. That is why it is called a cause and effect relationship. Okay, when we say, okay, digital marketing has an influence on sales, digital marketing has an effect on sales, so all these are basically cause and effect types of the relationship. In such cases, we have to use regression, not the correlation. Okay, so regression is different, correlation is entirely different. So usually we don't use correlation to accept or reject the hypothesis if our hypotheses are causal in nature. Okay, so first thing. The second thing, regression is just like a linear equation. It follows the linear equation. Okay, and I will explain in a while how it is different than correlation and what is actually regression is. So let's see, this is regression. Okay, you can see this equation. It is same like your correlation, but it follows this equation. Okay, so this equation is very, very important. Now let me try to explain these concepts. Each one of them should be very important and you have to understand. Okay, so y is your dependent variable. Okay, so y is your dependent variable. Okay, so this is, for example, in our case, sales. Now this is B1. In the regression, in the correlation, it gives us only R. R is just minus and plus. So we cannot determine the exact location of that line. We cannot predict. We can just see the strength of relationship. It tells us strength of relationship, not exactly the nature. Okay, so why the nature is not there? This is beta naught. Beta naught, or sometime we call it alpha. Okay, so this one is basically this y-intercept constant. Okay, sometime we call it a constant. Okay, so this is constant. Now the question is this: in the correlation, the line was started from here technically, but you see here in regression the line is starting from a different point. Okay, now from where this line intercept the y-axis is called your beta. Okay, beta naught, beta 0, or constant. Okay, we call it C, constant. Okay, clear? So here it's different than correlation. So first value, beta 1, is telling us, beta naught is telling us this value, or we call it constant. Okay, constant, remember. Sorry for this amazing writing, but first my writing is like this, and the second one is I'm using mouse pad. That's why it's difficult for me to write. Okay, now this value is constant. Okay, So constant mean from where this line is going to touch the y-axis, okay? So this is constant, okay? Now this one is beta 1. Beta 1 is, we also called slope, or we call it, for example, we call it how much this line is inclined. You know, here this line can be like this line can be like this line can have a lot of options, even starting from this point, but this line can have multiple options, okay? So these options means that how much this line is inclined with the x-axis is called your beta naught. And also in simple word, it tells us the strength of relationship, okay? I will explain it a bit later more in detail, okay? So are you clear about this point? So beta 1 is basically the your inclination of this line, okay? So inclination of this line with the x-axis, okay? Now here we have another term, this is called E. E is your error term, okay? So this is the error, because this is the predicted line and this is your actual data. So the difference between actual data and predicted line is called error, or we also call it standard deviation, ST, okay? So we have, sorry, residual, not standard deviation, we call it residual. So this is called a error term, okay? Error residual. So we use these terms in the regression. Now you can see that the regression is more comprehensive, and in the correlation we have just one or two things. For example, here in the correlation we have just R value. There is no error, there is no XY intercept, there is nothing. It just tell us the strength of relationship, okay? In simple word, it will tell me if I increase 1 unit of X, how many units of Y will be increased. This is simple R, okay? Let me tell you again, it is very important. You should write this with your notebooks, okay? Now, in this simple correlation tells us if I increase 1 unit of X, how many units of Y will be increased, okay? So this is called correlation coefficient. But in the regression, we are not just concerned with one, what I say is one value. We are concerned with the where this line is going to be start, how much this line is inclined with the x-axis, so we can predict our values very clearly, okay? So this is how simple, okay? Clear? Okay, if it is clear, is there any question you want to ask? So the next step, we are going to use SPSS now to do all this in practice, okay?
Okay, I'm sure our clip was a bit long and we had some 2 or 3 minutes to complete, but our time is already spent. We had some technical challenges with my network here where I am, and somehow a bit of our time was consumed. But I sincerely want to hope that for some of you who are like me with very little knowledge on statistics, I hope that the clip would have highlighted or given you some information where you can start with, especially on what is the difference between the regression and correlation, and what is the difference between the descriptive statistics and differential statistics. I really want to go beyond this because our time is already fast spent. I would like to stop right here and once again thank you for turning up in big numbers this morning, and I want to take you direct to our next session. I would like to invite Professor Michael Kuche to take us to the next session. Thank you very much. You have been a very good audience, and I pray that you continue listening to the presentation in the next session. Over to you, Professor Michael Kuche. I hope you are already logged in. Yes.
Okay. Good morning. Thank you so much, Joseph, for taking us through the morning session. I must say that the session has been very good, and we must appreciate you. And also, I want to appreciate everyone who was able to log in the early morning session. Again, this morning, I want to begin by appreciating our mentor, Professor Joseph Ntai, for the mentorship, for the support, and making sure that we continue engaging each other, and also further learning more and more and more and growing. Before we start, of course, we are continuing our series, but before we start, allow me to appreciate everyone who has been able to make it this morning. We have our senior colleagues and PhD students from all over the world. And allow me specifically begin by appreciating our mentors and senior colleagues. With us, we have Professor Laura Orobia. Professor, you're welcome. We also have Professor James Kagari, you're welcome. Dr. Hamad Walgembe, we appreciate you for making sure that we move in this direction. I know for some of you who have just joined the forum, Dr. Walgembe is our coordinator, and he does a lot of things, making sure that we move together. We also have the student leaders. I can see Slavia is there, Bernard, Wabkala, Joseph Elasu, and many others whom I may not be able to mention all of you this morning. I think we have been going through Professor Joseph Ntai together with Bosco Amerita have been taking us through the first set theory, philosophy, and methodology. And I must confess that it's a very interesting methodology for analysis. And I think as a Socrates community, this should be able to help us to grow more and strengthening our insights and making us be able to conduct very sound studies. Because all of us appreciate sometimes the limitation in the advancement in scholarship could be the result of the methodologies which we are using. And most times, choice of an appropriate methodology will help you to really conduct studies which are credible, which advance scholarship, which advance theory, which advance practice, which help us really to make a significant contribution. And I must say that through this platform, we have been privileged to learn different methodologies by different scholars, by different PhD students, by different senior colleagues. And I think that is the beauty about this platform. And again, I must commend Professor really for this initiative, because at one time, We took almost a week dealing with qualitative data analysis and by different professors, different doctors, different PhD students, people really who have made a contribution. So again, this morning, allow me take this honor to welcome our own Professor Joseph Ntai and Bosco to take us through the fuzzy set theory, philosophy, and methodology. Yes, Professor Bosco. Bosco, are you on?
Yes, thank you so much, Professor. I think I can
are you
start.
picking up?
Yes, Professor.
Okay, please.
Yes,
so, yeah, please. You're welcome.
Okay, thank you so much, Professor Koche, and senior colleagues and my colleague learners. We will continue to this session, which will be running. Hopefully, today we shall do some bit of running the software and seeing how the data would be possible to analyze using the QCA software. And we might not be able to use the R because then we might need some time later to come back with the results on R. So today we shall entirely focus on the analysis, which we think should be able to add value to the last presentation. Professor, I know that we will work out the arrangements on how to get the material shared, like the last session had brought to the board. We shall only eliminate a bit of the only issue was that some of the material is part of the writing of the thesis. Social Professor and I will guide on how to share it. We shall also share some of the books that enable the material to be easily applicable. So subsequently, you'll receive this as well. Professor and members, we can do a recap of what we did last time, a bit of it, just to refresh our mind. At the very beginning, we addressed ourselves to the qualitative comparative analysis, the QCA methodology, under the set theory. And session 1 addressed the set theory and the context of the whole methodology. And we also introduced it to the various components of the QCA methodology, which entails the crisp sets that ordinarily would mean the binary choice or dichotomous sets. And then because of the weaknesses in this crisp set, there evolved the fuzzy sets, which is ideally the fuzzy logic. And this is an improvement of the crisp set, which was the initial operation of the QCA methodology. Now it has tended to evolve into the third level or multi-value sets, MV QCA. However, literature indicates that that's not yet very applicable across. So the most applicable is the second fuzzy logic or fuzzy sets, or in short QCA. However, these two tend to operate more or less closely together and trying to cure. So it's a combination of both qualitative and quantitative practices to analyze data. And it's not meant to compromise the status of either the qualitative or quantitative analysis, but it tends to contribute and improve an improvement in the shortcomings of each of the qualitative or quantitative analysis. So this is the preview of the initial. Now, the last week, we also had a brief assessment of the types of the sets and how they are measured. We looked at their properties and how to establish the boundaries. And this idea element, we looked at the calibration. Calibration is the similar, is kind of similar to measurement in other statistical analysis. So in this methodology, we deal with calibration and how to attribute these sets in these cases into sets. Then we also looked at the various approaches. We looked at direct and indirect approaches, and we emphasized that the latter was the most used. Then we assessed briefly on the truth table, which is the ultimate tool that enables us to run. Maybe at the end of this session, we will try and look at how the software generates, runs the table, the truth table, how it operates. But I must emphasize that today's session, when we run the data, we'll give you the highlights. We're not going to use the actual data that we run. And then we also said we deal with the Boolean algebra, and the Boolean operators we're concerned with are the three: the and, or, and the not. This enables us to minimize the model and arrive at the most sufficient model that ideally gives us the target of our concern. And it also enables us to assess the hypothesis that we'll have developed and give results. So that said, this week we will therefore deal with analysis. We'll just take you through the basis of analysis of the necessary and sufficient sets. I mean, sufficient conditions, because this is the centerpiece of the analysis. We tend to want to develop sufficiency. And before getting sufficiency, we will seek to assess the state of necessary conditions. Then we shall assess the goodness and the strength of the relationship. And that means we shall be assessing consistency and coverage. So this second element leads us to doing the 3 and 4. Coverage essentially means the triviality of the relationship, how trivial or not it is. Well, then we shall also look at the few parameters of fit, and then fit in terms of the deviations. What are these deviations that arise and how they should be able to be handled? So the post-analysis, if we took like 1 hour doing this, then we shall run like 1 hour, say 10 minutes, then we shall run we'll try and use the software to run some basic data to just give an indication of how it should be operation. So the post-analysis is basically now the reporting. You generate tables, you generate the Venn diagrams, the box plot, the plot, XY plot. All this we may not be able to give you today in this, but we shall show you how the software can maybe generate the XY plot and that graph, and how it is possible to analyze your data from that graph. But we will request for some time to come back maybe one session later in the course of the progress. I'm sure Professor Antai will advise on when we are ready. Then we can be able to run you through the data that we shall have run through R or with FSQCA. That may be in 2 weeks or so. But we shall notify you. So we will go to the beginning of this. So I'll take you first to the concepts of what each of this entails before we will do the data part of the software and the software. So professors and members, we looked at the analysis of the necessary conditions. We said maybe to link, before we get there, to link this assessment with the previous video clips. You realize that the video clips 3 to 4 o'clock was addressing issues of correlation and regression studies. Ideally, if you realize they are talking of causal effect as well, and in this, you will still refer to the 3 assumptions. That's where you'll get the difference between this methodology and the correlation or regression of studies in relation to causality and effect. Because these studies, essentially emphasize on the 3 assumptions. Conjunctural causation that we looked at in last week, in which case we said conjunctural causation addresses more than one condition to arrive to explain the outcome variable, the outcome of interest. While we also looked at the issue of equifinality as one of the assumptions, the core assumptions of the QCA methodology. Equifinality is indicating that you have several ways, several routes to arriving at a similar outcome. And then we also addressed the issue of causal asymmetric causation, in other words. In which case, if you looked at the correlational effects of the R, if you paid attention to the graphs, once you have the positive correlation equal to 1, it means as the conditions increase by 1, the effect of the outcome increases by 1. In which case, if you reduce the condition X by 1, the outcome also reduces by the same. So the difference between this and the correlation or regression of studies is anchored on those 3. This one, it says under asymmetric causation that once you increase a condition by 1, the output may increase by 1 or may not. Or if you reduce, it is not necessarily that the outcome will reduce by 1. It indicates there are other conditions that support the outcome to stay at 1. That is the multiple causation. That is why we are dealing with multiple causation. So we'll link that to the previous studies just on that basis. So we say a necessary condition X is a superset of an outcome if it is a necessary condition. In other words, it is the majority, the conditions are the majority in explaining a specific outcome. Wherever the outcome is, that condition must exist. That's why it is a necessary condition. It always has to exist. However, if it's a sufficient condition, we will have a minimum amount of that condition being able to explain the most outcome. So it means that the outcome is greater than the amount of conditions available to explain it. Whereas necessity means that this must always be there to explain a specific outcome. As we shall see in the area diagrams, much easier for us to interpret. So as we illustrate below, there are 3 basic steps involved in the analysis of this. And these are part of the reliability tests that we engage in, arriving at the reliability of the analysis data. With consistency, empirical consistency, and coverage, which is also analysis of triviality. So coverage, in other words, when you hear about it, it's more of the analysis of the R square, in otherwise the correlational studies, than the conceptual meaning. So the main parameters of fit under this is the necessity, in assessing necessity and sufficiency are these two. So we shall pay attention to this when we're running the software in about 45 hours time. We'll see how it operates. Then we shall also assess the goodness and the strength of the set relationship. In this case, our interest is still the same: consistency of necessity and consistency measurement, then the parameters of fit. So here, under consistency of necessity, we are trying to assess whether the condition is a superset of whether it's the majority. Does it constitute the major? Is it the major player in determining the outcome? So superset. Remember, we're dealing with the set theory. Then we're also trying to measure the consistency, because the consistency will normally give us specific measurements, which under the theories, under theoretical and the literature, we have basic standards below which the measurement will be weak. If it's above that, then it is acceptable as being able to explain the outcome. So we shared that last week, so we shall not give again this year. The numerical expression of the extent to which empirical evidence is in line with the set. This is the necessity, the set relationship. So have a condition, a causal relationship, a combinational relationship that should be able to explain the outcome. So the numerical expression of this is our measurement tool under consistency. So we transform consistency into figures. And that is normally generated by the software when we run the data. So we shall see the consistency measurements at that stage. Then parameters of fit. And this indicates the degree of such deviations. And the deviations are the basis for which we eventually, because we can contribute new information to the literature. Because your data may, somebody's mic might be on, our data may speak to deviations and allows us to assess the goodness and strength of the relationship. So these are the counterfactuals that become essential in giving us some new information. And this we shall also look at how they play, how they come into play at the end of this session. And these counterfactuals involve the application of the simplifying of assumptions that eventually enable us to explain why we are deviating from the literature or theoretical standpoints. So when we look at this, when we talk of consistency, perfectly consistent means this outcome is explained by, this is why this is the superset of X conditions by explaining this. So the outcome is perfectly consistent with the existence of this condition. This is just a figurative outcome. Now, you remember we had indicated through the application of the Boolean algebra, it means that this complement indicates the absence of the outcome. So this is the absence of the condition. So as you see, this is the perfect consistent. It's consistent, but when you come this side, it indicates a slight inconsistency, that there is some portion of the outcome that is not explained by this condition. It's inconsistent. There's need for us to explain this outcome, which is not caused by the condition X. And this is why it is inconsistent. So we'll be able to assess that subsequently. So slightly inconsistent illustration represents a logical contradiction. Sorry, I think I typed wrong. It's supposed to be a logical contradiction. That the outcome with that the outcome exists without the necessary condition. So it's inconsistent a bit. It's supposed to be perfectly consistent. So consistency measure indicates how much the empirical evidence deviates from a perfect superset, and we've just seen it. The evidence tends to deviate. There is some part of the evidence that deviates. And to calculate the consistency measure, we deploy this methodology. This is more in the software application. So we tend to have methods for each necessary condition, even sufficiency conditions, even when we're testing for the proportional reduction in inconsistency, we'll also have its own methodology. So this is one of it. The mathematics behind it may not be necessary for now. So we'll get to, if we have to explain this in a diagrammatical format, just assume that these are colored, these individuals of colored are part of the actors, the producers of biofuels, my study in biofuels. Now, one of my conditions, super conditions, is a digital ecosystem. The outcome we're predicting is, does this cause the commercialization of biofuels, for instance, if you consider this. Now, when we plot this on the XY plot, we will be able to see that some producers are performing in a very weird setting, as we shall see. This D, for instance, indicates that, as you remember, these are the calibration anchors between 0 and 1. And between this, we're getting the midpoint, center of ambiguity, the same as here. So the midpoint. So anything below this coming down is not very much relevant for. The same applies to this. Anything below this way is. Now, however, we realize that D is above a 0.5, the minimum, the extent of ambiguity. And so it means the outcome is higher than the would otherwise be the conditions. So we'll be able to explain what other conditions exist that create the outcome to go higher. So sometimes when you find some outcome could be ranking at this level. So if you find a producer is performing at this, commercialization is at this point, for instance, it means that, or for instance, at this point, it means that the condition is low, very low, but the outcome is so high. That means it's inconsistent, because then you have very less conditions explaining a high, very high outcome. That means there are other reasons, and that's where the other assumptions, the assumption of conjunctural causation and it kicks in. There are some other explanations that you have to give to explain this, other than digital ecosystem. While when we have a perfect consistency, it either falls where Bob is or somewhere around this. So this way you get the sufficiency conditions falling around here, then the necessary conditions all falling below the diagonal, as we shall see subsequently. So to explain this further, the consistent DCKs, this is the deviations that are in kind and in degree. So in kind, just by their location, where they are located. In degree, the assumptions of degree kick in terms of the degree of their value, membership value, the 0 to 1, the 0 to 0 to 1. So in terms of degrees, where do they fall? So in terms of being, if we can see from here, the degree is determined by our figures, but in kind, where do they fall? Above or below the diagonal? So we shall assess this subsequently. There are three inconsistent cases: Mark, Fiona, and D. Mark, Fiona, and D, as I highlighted that. For all the three cases, the membership in the outcome exceeds that in the condition. The outcome is higher than the condition. Mark is a member of both X and Y, if you see, realize. So here is doing well because the condition is explaining the outcome. Is a member. This is the sufficient level. Fiona is not a member of either X or Y. It's not a member of this set. So it's outside, as we see the center of ambiguity. It's just below the. So when we're doing analysis, we shall determine where our cases fall in the basis of that kind of a graph. And we shall get this when we run the data shortly. So we seem to see they contradict the notion that the high application of a digital ecosystem is needed for a high commercialization of biofuel, which is much less than the D. So if you see high application of the digital ecosystem would explain a higher commercialization of biofuels. This would be Mark's case. But in this case, the application of digital ecosystem reduces, but still commercialization under D is still high. So there is something to explain this more than what is a digital ecosystem explains. So the assumptions kick in. So we have to go back to literature, go back to the case and understand the case, why it is so. This is still where we now bring in issues of iteration with the case, iterative studies. So cases like Fiona and Mark are deviant consistent in degree, deviant, they are deviation. So let me just go back, sorry to keep you back and forth. Fiona and Mark, deviant. And D, these are all deviant. For all the three cases, the membership in the outcome exceeds that in the condition. Mark is a member of both X. I've already explained this. Fiona is not a member. And we have understood why this is so. They contradict the notion that high application of the digital ecosystem is needed for. I've just explained this. So cases like Fiona and Mark are deviant consistency in degree. So DCK and DCD will always appear, and we can be able to explain them in that way. Cases like the D are called deviant consistency in kind cases. And we want to perform a follow-up interview. That's why I was saying once there are deviations, then we have to go back and make a follow-up iteration of the analysis with the case. So that we'll be able to know why are you deviating from the standard of literature and theory. So that we're able to explain, and this is where we contribute additionally to the literature. So the best scenario, of course, is when there are no DCKs, there are no deviations in kind. So you don't need to have those that fall outside the average, the point of ambiguity. So empirical relevance is the other, as we noted earlier. We want to test the coverage. The triviality is part of the variability tests. Once we have identified conditions that are consistently necessary for our outcome, as we've just seen, we can be able to plot or do other tests that we shall see subsequently. We turn to the question of how empirically, what's the importance, how its coverage is outstanding. So in this case, we run these two tests: coverage necessity and the relevance of necessity. Now, a necessity claim is trivial if there is a big difference in size between the outcome set and condition set. We shall see this, I think, better to explain with figures. either because the outcome is very small or because the condition set is very big. So eventually, this triviality will be explained in figures. So we'll be able to explain this much better 2 or 3 slides ahead. Now, as I indicated to you that we have coverage also has its own formula. So this is still a coverage for necessity. There is also coverage for sufficient conditions. So they are different in their setup. The equations are set up differently. So when the condition set is much bigger than the outcome set, then the coverage is quite stronger. The coverage value ranges between 0 and we had indicated to you last time that these coverage values, the closer to 1, the much better. And the lower the coverage value, the weaker the explanatory power. And this one we had given you, it's either it will be understood as trivial in terms of explaining the outcome of interest. So we have the X-plot coverage, and this is more when we plot it on the graph, we'll be able to see the X-plot coverage and be able to assess each of the cases. And as long as they are close to the diagonal, as we had seen before, when they are close to the diagonal, then they are closer to a strong or much more stronger explanatory power to the outcome. So the more the cases are located far above the diagonal, the more they reduce the coverage of the condition. So as we said, this other, if you have the box, as we said, those that locate but on the left, then you find that the explanatory power is reduced, because then as we move towards the left, you are reducing the condition, but the outcome is going up. So above the diagonal, the outcome is higher, but the condition that explained is weak, is less. So parameters of fit, we always check consistency first when assessing the relationship. Then we interpret the coverage, and then also the run. Then the rule of thumb is that if we have necessity posting a 0.9 and above, then it is strong enough. It's sufficient. It's able to explain. And the coverage and the run, no such strict threshold yet established, but research practice indicates a 0.5 and above could be good, but less than this would be a reason for concern. Once you get down to 0.5, you find it is weaker. Explain the causal effect, the causal power, causation power. And we remember, we noted issues of causality under the methodology here, and causality under regressional studies are not necessarily the same in terms of explanation, because this has conditions, and the conditions are not necessarily normally one, but the conditions are a combination. So these are configurational studies, configuration of conditions that explain an outcome. So they are not similar to the experimental studies. Causation in methodology in the QCA is not the same as the causation and experimental or statistical studies based on the assumptions. So then, part of assessing empirical triviality, the coverage, is done using the visual inspection. And we've just given you a clue of the X-plot. We shall see how this is set by the software. And then sometimes we can also run the histograms and the X and Y. Any potential necessary condition must also be conceptually meaningful. And indeed, that's why if we have counterfactuals, we must align it with, we must explain it to defend our position or to subscribe to a new direction other than what theory and literature is suggesting. So it must be conceptually meaningful. Even if a condition displays a very high consistency in sensitive value and is not still, we need to engage in theoretical iteration. We iterate with theory and literature, that we do not deviate seriously for that. That's about sufficiency. I mean, that's about necessary conditions. So we evolve into the sufficiency stage. Now, sufficient conditions, sorry, I think sufficient conditions is the next best that we are targeting to establish the model of interest. It is the ultimate. We want to test for sufficient conditions in most of the studies. Which are these conditions that ultimately can cause the outcome? They should be not the majority. The other side is they should be majority. They are necessary. This time, they should be the minority that can cause the outcome, the sufficient, those that are exclusive to cause the outcome. And that's why in its equation, you'll find this, the conditions are less or equal to the outcome. Less or equal, they are sufficient. These are fewer, but they cause the outcome of interest. So here, sufficiency and necessity, they mirror each other. However, in this Euler diagram, we are able to see the XY. So the other time you realize the X was the was a majority outside. So the conditions were majority, they were major. They exist wherever there's an outcome. But in this case, sufficient conditions will be the most minimum. That's why we brought in the issue of the Boolean algebra will tend to give us the most minimal conditions that give us the most outcome. And this is how the Boolean will be able to show us. So this is the absence of outcome, then absence of conditions. So you realize, like we emphasize, that this methodology tests both presence and absence of the outcome. That's its standard. And so we will move to the next to see the box plot, the XY plot. So the sufficiency of the XY plots are a powerful tool to visualize the relationship in the fuzzy logic. We are visualizing most of the times, because then we're able to tell which cases play the most role in explaining. And then we shall be able to determine why these cases are this way. Why do they perform that? And as you realize that the ones located below the main diagonal, marker D and Fiona, are cases whose membership in X exceeds that in Y. These are still necessary. Remember, X, Y, and mark D and Fiona, assuming we had them. The last time we see this are now more of the necessary conditions, because this diagonal is our target. Because this Bob, for instance, will post the maximum 1. It will post the results to be equal to 1. And that's why we say, as long as they are in this triangle, then the sufficiency conditions will have been established. Because at this, you have the most conditions that will explain the most outcome from this territory. That's why we will want always to test using the XY plots, because it will give us a very quick assessment. As you can see, Carl here is an outlier. It's a counterfactual of sorts. You have to explain it more, because you have this condition, this is the X condition, and this is the Y outcome. Now you can realize that if you are to gauge this, Carl has minimum of 0.2 amount of condition, explaining the biggest amount of outcome, which is close to 0.8 or 0.9 something. It means this condition alone cannot explain the outcome Carl has. So there's additional assessment we have to do on this case, particularly to determine what other conditions are supporting the existence of this outcome. And that's why we say conjunctural assumption or conjunctural causation. There are other conditions that explain this outcome. conjunction, the intersection, if you remember in the set theory. So then we move into consistency of the sufficiency, because we have to test and measure it as well. So sufficiency, consistency scores are expressed. This will express the empirical, how much the empirical evidence at hand is in line with the formal logical claim, the logical claim of commercialization of biofuel. So you have the conditions that support it. So how much is the evidence supporting the claim of commercializing biofuels, for instance? So the same formula of necessary conditions applies, as you remember this, except that the denominator is, in this case, is the sum of all cases. So it's more of conditions, the sum of the conditional conditions rather than the outcome. Remember the last one this was the outcome variable conditions of the set. So here we shall not go in the detail of the mathematics of it. We shall have to run faster than that. The more the cases fall below the diagonal and further below the diagonal, the lower the consistency score. So we have seen that in the illustration, and this ranges between 0 and 1. Still, our range is the same. So even when we run the data, you'll be able to appreciate that this is normally where we want. Even transforming our data, will transform it between 0 and 1. And the higher the value, the more the consistent, the empirical pattern. So the range should most times range between 0 and 7 or 0.75 or 0.8 value as an acceptable standard to explain consistency. And this means that sufficiency can be established if the data posts above this. And according to Ragin, this is one of the authorities that established that is a proponent to this methodology. So then the deviant cases still come into play. The DC case, deviant consistency in kind. Any case below the marginal diagonal is a deviant case. In this case, we are dealing with sufficiency. So once they are below, that means they deviate from the standard of sufficiency, which should be above. So simultaneous subsets relationship will now be measurement. So we will want to seek to know the proportional reduction in inconsistency, because if they're inconsistent, how can we have this inconsistency reduced? And that is one of the reliability tests we want to assess. Simultaneous subset relations denote a situation in which one and another condition is a consistent subset for both Y and so you cannot have a condition explaining the presence of an outcome and at the same time the same condition explaining the absence of the outcome. So it's not possible. So that will be inconsistent. So we want to try and reduce that kind of inconsistency. So that is what this measurement will bring. So that a specific condition should be able to explain the outcome variable than having to explain its absence. So other conditions should be able to explain its absence. Remember, we still noted that this methodology tests both presence and absence of the outcome. What conditions, what configurations explain the presence of the outcome, and what configurations explain the absence of the outcome. So as you realize, we can give the Euler diagram figure above. From the above, X1, these are consistent, X1 and X2. This explain the outcome Y. Whereas X2 explains the absence because they are perfectly. However, you see these are overlapping. This overlap is where we bring in the issues of inconsistency. Instead of explaining this, X1 explaining this, X3 tends to explain Y as well as the absence. Remember, the Boolean operators indicate this is the absence of the outcome variable, while the outcome existence. This, But this inconsistency of condition X2, X3 is where inconsistency comes to play. The same as 4 is inconsistently explaining both the absence and the presence of the outcome variable. So this is what we tend to minimize using the proportional reduction of inconsistency measurement, PRI. So that overlap is what we want to try and minimize in degrees. So the PRI is a numerical expression of the degree to which a given condition X is a subset of only outcome Y rather than also the outcome, the absence of the outcome Y. So the rule is that PRI should be above 0.5. The lesser the possibility that the given set is sufficient for a given outcome, PRI value lower than this is deemed not sufficient. So once you have it falling below 0.5, there's a problem in your analysis. And so this one involves running the software in more sophisticated approach. And I know that the formula is given as this. So for now, there's no basis for us to bother on the formula because in any case, what you only need to know is that we're trying to minimize the inconsistencies. And this is also generated by the software. So if you don't wish to bother a lot, it's better for us to know the meaning. So then the coverage of sufficiency, we noted the coverage on necessity. Now we need to also have the coverage of sufficiency, and gives us that by that formula. So the analysis of sufficiency and limited diversity. In this case, once we analyze, we shall be able to have logical remainders. These logical remainders are the outcome, the outliers, the counterfactuals. These are a problem. Because in your table, when you generate the output from the software, in the output column of the truth table, they are denoted with the question mark. Once you see question marks in your table, it means these ones, they are not speaking to the literature, indicating that it's not if a specific combination of conditions is sufficient for the outcome. Normally, you have data that does not conform with literature, with the theory. So it becomes a logical remainder. So you have to treat it as a counterfactual. The treatment of a limited diversity is governed by the standard analysis. So we shall see how to analyze it. We shall get to that level where the standard analysis will generate the data. And then once we run the standard analysis, there are 3 solutions which are derived: the conservative, which is normally complex, parsimonious, and intermediate solutions. We explained what each of these was at the last section. What you only need to remember is that this does not include counterfactuals, doesn't take into consideration. Whereas this takes into consideration the counterfactuals, those outliers, parsimonials. Now, these intermediate will take into consideration those counterfactuals that speak to literature, that are in line with literature. So it's careful when addressing it. So we will get to see what they are. Standard analysis, protocol, and the rest, these are still the same. We'll get the analysis done and we'll get these outputs. So the principles that govern this is that conservative solution does not include any of the remainders into the logical minimization using the Boolean algebra. Parsimonious, however, includes all the remainders, the counterfactuals, in the most parsimonious way of representing empirical facts contained in the truth table. So it combines all. While intermediate tends to take those remainders, those that went into the parsimonious solutions, as long as they are in line with the theory. They consider those that are specifically speak to the literature and theory. In line, they can be explained. So their direction. The interpretation is more complex than the most parsimonious and less complex than the conservative. So these are the 3 separate solutions that eventually generate and models that we will eventually go. We will go by one of the solutions, not all. then you'll be able to defend why you chose one. Why did you include the counterfactuals? So depending on the ability to defend the counterfactuals or the outliers, then we're able to proceed accordingly. If however you can't, then you proceed with the complex. So this is figuratively what it means. Outcome equals to 1 is a complex solution. So then we have, once you have this complexity, you have not included counterfactuals, you will now have to get into an intermediate solution that includes counterfactuals. Then the PS is the parsimonious solutions. Once you have you may decide to include simplifying assumptions. And this means we're going to get assumptions that will now explain why we are departing from literature. These are simplifying assumptions. Those assumptions that enable us to explain our position, why the evidence we have, why the data is speaking against the literature. So then the innermost circle denotes all the truth tables. Okay, we'll just explain this. So we will have the enhanced data analysis of counterfactuals or simplifying assumptions. The standard analysis assumes researchers may inadvertently make an untenable assumption. That is standard. Assumptions are untenable if they are logically contradictory or run counter basic or uncontested knowledge of how the world works. So these assumptions, once it is contesting the normal, possibly will be contradictory logically. So you may not want to survive with that. But what is possible to be tenable, you can survive with, is what tends to explain more the reality of the world, how it works. And then to rule out the possibility of including such untenable assumptions, we deal with enhanced standard analysis. We shall not go to this level because it will involve a lot of time to analyze that. So it blocks all logical remainders, rows from being included into the process of logical. That would otherwise be untenable. So this one just eliminates the enhanced standard. It just eliminates those outliers. So then contradictory simplifying assumptions, those occur when the same logical remainder row is included in the logical minimization of occurrence. So if you are going to include in the presence and absence, then you are having to deal with the contradictory simplifier. So you can't use a simplifying assumption to explain the presence and the same simplifying assumption to explain the absence of an outcome. It will be logically contradictory. That's what it suggests. So such logical fallacies must be avoided. Otherwise, we risk having untenable explanations to defend the position. So the post-analysis in this case would mean we will do the test for robustness. And this robustness and diagnostic tools, quite a number, but we will restrict ourselves today not to deal with so many of them. So this is designed to enable the reader to investigate to what extent these results are robust, and we shall deal more with the consistency for today and coverage. Those are more the focus of the robustness. And it tests more the application of the Boolean algebra operators. So regarding the selection of calibration, we will also test that. And that's how we are testing for the robustness and diagnostic tools, such as when cases belong to different groups deal with issues of clustered data. Now, this clustered data is more in an advanced setting, so maybe we'll just have to note what it is and not explain. So when we're assessing robustness, we want to look, there's a specific protocol that we can deploy, more so in the art software. It will test the sensitivity of the ranges and the fit-oriented robustness, and then the case-oriented robustness. So these are all the different tests that we need to engage. And sensitivity, ranges, we'll test with the calibration thresholds. Remember the anchor points of either 1, 0.5, or 0, or something 0.1, depending on whichever anchor point you choose. So how they behave with the application of the Boolean formula will be the sensitivity levels. If they change significantly and change the Boolean formula, then it means it is sensitive. However, if those anchor points, the ranges, the calibration does not change the Boolean formula of sufficiency significant, then it is robust enough. So fitness-oriented robustness and case-oriented are both allow researchers to evaluate how robust the initial solution is to multiple, simultaneous, and substantively plausible changes. So we'll do several changes in a number of things to assess how the behavior of the data would realize. So this is basically being able to test the possibility of changing your data and operators that you have set out. So it's easy to deal with. All these are simply, these three can be run under the R set methods package. This is also software which is available for free online to run the tests. However, for today, we shall use the QCA 3.0 software package. So the R, as we appreciate it further, we shall get back to when we're discussing the one more slot if we are given to discuss the results in detail on how it's set up. Then tackling the notion of robustness, we need to engage with two questions: robustness against what, and how are robust results defined? So this is the two questions. So against what? Changes in the raw consistency, changes in calibration, and changes in frequency cutoff. So these are all matters of when you are establishing your model, for instance. So we have to test in terms of calibration. When you change the anchor points, these are the cutoff. What's the response of the outcome solution? Then, how are robust results defined? Some consider the result as robust when there is no change in the Boolean formula, the solution formula. Others consider it when parameters of fit are rather stable. So those parameters of fit are the stability. If we see that's the question. Sufficiency. Okay, it's disruption on the background. When solutions differ in terms of formulas or fit, but they remain as set solutions. So we've seen the parameters of fit earlier. So once they don't change so much, when you have changed the calibration techniques, then there's a lot of robustness in your analysis of the value. So this honor introduces us to a more comprehensive robustness test, which can also only be run by R. So as we're not going to run R today, we will not bother a lot on this. The protocol allows us to assess both the various sources of robustness in terms of calibration, the threshold, and the cutoff. And this is based more on the operations of Boolean expressions, the parameters, and then your set relationship, the type of cases, how do they behave. So the protocol involves evaluation of multiple sources of robustness and their various consistencies on the solution. Because our target is to assess the behavior of the solution if we change the parameters and rather the degree of involving. So there are three main steps of protocol of getting this data: sensitivity for fit-oriented robustness and evaluating for case-oriented. Now these are done easily by the set, by R. Okay, so for safety reasons, we can just explain what they are. And so sensitivity ranges are the same as we had already explained. You are simply, we're simply assessing how the solution is responding to changes in the parameters set. And I've already just explained this. and whether the Boolean expression of the solution changes significantly. So sensitivity is already addressed. And then we want to explain how fit-oriented robustness comes in. So in this one, it's also an application of the R software. It essentially involves the comparison of various parameters of fit for the initial solution, and then the robust score, and the minimum and maximum tests. So once we set them, we simply set, we code the data, and it will generates for us this result. And there are specific cutoff points, and the same applies to this. And more so, we can be able to test the plots using to assess it visually, case-oriented robustness. We have already seen how this behaves. Then cluster diagnostics, these are inspecting consistencies and coverage values. We have just looked at this based on clusters and pooled consistency between consistencies, among others. So the clusters, those are the supersets that we have already referred to. So what is the pattern of behavior of the data once we have supersets? So this brings us to the second last slide that I thought we would be able to go through the basics of the software. If a small practical session to see if we can be able to deliver this in the next 30 minutes or so. And Professor, I don't know if this is okay with be able to proceed to the next level. Just seeking your guidance on that.
I think you continue, please. It's okay.
Thank you, Prof. So here I will close that, and now we will want to take ourselves to, as we noted, let me just get you direct to the data that possibly might be applicable. As we noted, this software applies more to data that is CSV operated. CSV is the same data you apply on Stata and SPSS. And at the beginning, I think we just see where the software, if you are to run the software, just show you how it should be able to appear. Once you have the software, let me just see where it is. Okay, once you have run the software, when you download it, it will generate you all this as operators at the background. If you just went on Google and you search for QCA software 3.0, that's the latest, you'll be able to link you direct to where you can download them. Be sure the site is safe. We have no control over that, so it's about individual to check for the safety of the data. So we will run our software from this. It gives us a similar. I don't think it's able to show from there. So most times I will close and be able to reshare, because I think it cannot share across that way. But if I share data fresh, next this, I can get to be guided on how to share. Okay, so this is how the screen will appear. More of an SPSS-like screen or sorts. So once you have your data, we will be able now to create our cases. You first, before you calibrate, we will be able to start just upload the data. So in this case, assuming we say our first variable will be the cases of analysis. So it will give us just the columns, just gives us the columns. We get to variables, then again add. So now once you have the cases as the first column, the next column should be the conditions, the sets. So assuming I said I have transactional costs as one of the super conditions, you will simply add. Then the next is biofuel attributes, say for instance, as the second. Then the third, you deal with, say, digital ecosystem, and you add. So in this case, you have set the first line of operation, and you want to have how many cases? Then you come to cases and you add the number of cases you have. The minimum is normally 10. So let's have 10 cases here. So it will generate for you the table for your 10 cases. So we're going to say we have case A, we have case B, we have, sorry, let me just use this to, we have case A, we have case B, we have case C, we have case C, D, E, F, G, H, I, J. Just assuming you name them, assuming you have cases that have their names. So the names appear here. Then you will go to now your Likert scale. Question the data you captured under your Likert scale. If and then you'll be able to get the means and populate them across. So assuming you have, say, your Likert scale measures between 1 and 5 points. That means depending on what case 1 tallied for transactional cost, assuming it's 1, then for biofuel, but normally it's better to first tally through only one condition. So what does case 2 give you? Say it gave you 3. What does case 4 give you? Say 4. Then this gave 2, this gave 1, this 5, this 2, this is 3, this is 1, this is 5. That's from your scale. The same applies to this. You could be able to have, so I'll just give, these are hypothetical figures so that we move to the next step. So it's just assuming we have these hypothetical figures. Let's see how we can, no, 6 is not in this. We have this and that. Now we have this as one from raw data captured. It's just raw data captured from your field, your tools from the field. We will now move to level 2. Once you've captured this data, it's advisable to normally save it, because this software is so sensitive. Once you enter a wrong command, it will close. Then you have to restart and you'll have lost that data. So assuming we said we're saving this as a test 11th. So once it closes, we shall be able to again open it and get back to the data without any problem. That's why we noted this is CSV saved. That's why we have these Excels with the weird A at the bottom. It's not just a, so it still brings us back the same data once you open it. So once we have done this, then I think I should be able to run through to the main data that I had initially shared. We will now use the data initially shared to enable us to move faster. So assuming we have this data that's just the same way we've established the other one. It's just that I want to have more points to be able to give us fairly detailed analysis. We will now move into the next phase of, say, calibration. Just let me just start afresh and get to the software. I think I had not opened the software. Just give me a second. I meant to share the software instead of the data and then open the data from the software. Yes. So we want to access that data. Let me see which one we calibrate this. This is the data in the same context we just entered. This is the raw data from our Likert scale tool and field data collection tool. So now we want to try and conduct the analysis of, we cannot analyze before we transform this data into the FSQCA, the fuzzy set user-friendly version. In this case, we need to calibrate it. So to calibrate it, we will come to your compute. It gives us this table, this window. I don't know if we've seen that side. So we want to calibrate all these variables and conditions into the fuzzy set operational. From this raw data, calibrate it into now into the truth table based on the anchor points we talked about. So for instance, this is we consider this being the outcome variable. So we shall do with the outcome variable and say, okay, we want to configure commercialization this into, let me just put it here fresh. We want to do this into commercialization of biofuels. Let it be called this. So this target variable is the outcome variable. It should equal to, sorry. So we calibrate. What are we calibrating? We're calibrating this condition, which is this one here. And once you have calibrated these conditions, then we now set the anchor points. And there you now enter the anchor points you established. Remember, we went through issues of anchor points. So here, assuming I said my topmost is a 5. Because in this Likert scale, you have a 5 point. So my midpoint, if I choose, I don't necessarily have to choose the middle. There's a reason, and I am basing on a certain scholar, on a certain principles. So I take 4.5. Why? Because I've taken above the middle, because there are fewer cases. So the more, the higher the midpoint, the threshold, the better the results. Most times. So the minimum I take is, say, 2. And from here, I'm going to say, okay, calibrate that. So it's calibrated this. As you note, all these points now fall between 0 and 1. Between 0 and 1. So it's transformed this variable into now a truth table and fuzzy set related. Then we again proceed to calibrate the next. Say we can calibrate this now coming this way so that it makes it easier for us to move faster. So we calibrate, say, transactional costs. We want to call it TC, say, and which we say calibrate. So we're calibrating transactional costs. And we're using the same anchor points, say 5. And then we have got to deal with midpoint, say 0.5. Then we'll deal with the minimum. Okay, this is 5. So it calibrates the transactional costs into truth table related. So this is now, it computes and it's calibrated. So we calibrate the next. We're now calibrating the biofuel products attribute. So let's call it this, then calibrate B. Then we put our anchors, right? Then we deal with 4.5. Then we deal with this to be the minimum to be 2. So this is also calibrated. Then we finally calibrate the digital ecosystem. So we could do compute. So here we do digital ecosystem, calibrate it into this. And what are we calibrating is this, and then we have the anchor 0.5. Then this is 4.5. And then this will be 2. So once we've done all this calibration, we have now the data calibrated into what FSQ can be able to run. So normally it's advisable that every step we do, we save. So assuming we say test run 11th. So once we've calibrated this, it means we are safe to start the analysis. And I'm going to take you through the basics of the analysis. So we'll run the truth table analysis. Now, once you run this, we want to set our outcome variable to be commercialization of biofuels. Remember, it sets negated as well as so both. So our conditions will automatically fall under this. And then you want to show the cases. It's okay, please run as simple as running this. So it gives us this truth table. I don't know if it is able to be seen that side. If it's not seen that side, it means I have to close and open again. If you don't mind, I think I have to reshare it. Let me reshare the truth table separately. Okay, this is how the truth table will appear. Now, as you remember what we're discussing, we have got the cases distributed. We have in total, we have the raw consistency, the PRI, the proportional reduction in inconsistency. You remember? So that means these two have challenges in inconsistency. This performs well, this performs well, even this has a problem. So what we do, inconsistencies, we now come to delete the code, and automatically gives you that delete rows with numbers less than 1, and set the commercialization of biofuels to 1 for rows with consistency greater than 0.8. So automatically it will now establish to us the minimum we need, and it will now set. So you can see all this consistency will now become our focus. Consistency 0.8 is our target. So these ones will be below and they're performing poorly. And if you remember, we said somewhere in our third last slide, we said we now conduct the standard analysis. So this standard analysis is what we will now, and as you see, it should contribute to the commercialization of business of biofuels when cause is, so it gives the presence of these causal conditions or absence. So you don't have to check in each of this because it will automatically give us the both present or absent, negated or present. Then we say, okay. So unfortunately, again, you cannot be able to see the data from that side. So I have to close this and maybe reshare it, because it posts on the other table where we had been operating, where the road. So just let me just try again and reshare. Okay, so this is now the data. Remember, this is the calibration we did, if you remember this. So our analysis now posts here on the right. I don't know if you are able to access it that side. And these were the calibrations we were doing. Transactional cost, for instance, we calibrated, and okay, let's go from commercialization of business. For biofuel, calibrated at anchor point 5 and 0 and 4.5, and the minimum to be 2. The same as transactional cost, biofuel, and then the digital ecosystem. So it gave us a truth table, and the model that we are operating is this one. The commercialization of biofuel is a function of transactional cost, biofuel innovation, and digital ecosystem by this algorithm. So remember, our interest was to arrive at the complex solution. If you note, this is the complex solution. Then also note, this is the parsimonious solution. And then also note, this is the intermediate solution. So these are the ultimate models we want to arrive at. Now, the bit about this is that it will now give us, in the complex solution, what are the operational models? What is the consistency? What is the unique coverage? What is the, so you look at consistency, it's performing above 0.8, which means the data fits. Only if we have, if the transaction costs are lower and you have digital ecosystem operating, is when we have consistent performance of commercialization of biofuels. In other words, now we shall be interpreting the data. In this category, so biofuel attributes and the digital ecosystem will give us a 0.9 consistency. While here, if we have transactional costs and low biofuel attributes and the low digital ecosystem will give us this performance. So the ultimate overall solution coverage and consistency is this 8.2 and 7.0, I mean 0.7 and 0.8. Now the bit about this is that it will indicate to you the cases that are performing well under the complex solution. So we'll have cases that with greater than 0.5, those that are above the midpoint, in terms of transactional cost being lower and the digital ecosystem, we have these cases, Mado, and a number of them, Kakira Sugar Works. So I'll be able to go back to these cases specifically. If I want to dig out more data, now I am the knowledge of which cases I am talking to. So it kind of speaks to the specific cases. The same applies to the parsimonious solution. So you'll be able to analyze. This one has only the digital ecosystem giving that, and you see the operations of the model will change according to each of these truth table operations. Now that's about the solution, but you can also be able to run. Let me just see if we can be able to run the. We can be able to run the descriptives. If we say we want to run the descriptives, all these of variable conditions, it will give us descriptives and how it's performing. Then we're also able to run analysis on necessary conditions alone. So here we're saying the outcome variable is our commercialization of biofuels. Then we have got the conditions. We have got transactional cost. We have got the biofuel innovations. Then we have got the digital ecosystem. Once we set all this, then we test their consistency and coverage. So you can be able to see the coverage of the necessary conditions. So then we can also be able to, what can we do next? Superset. You can do the superset. You can do analysis on any of this, but maybe we can just do the graph. We can also plot. Now, if we want to plot the graph, we will be able to set our outcome variable as this. Then we shall set our, let's start with the transactional costs, which cases and how they behave. Then we set our case ID as then we plot it. So it will generate the location of various cases. This is the plot we're talking about. So as you can realize that we have about so I can be able to tell which cases are behaving very well. Case 24, 29, 30, 31, 32, 34, 36. So I can be able to go to those specific cases and dig out more data and analysis. So the outliers are here, especially case 2 is an outlier, is a counterfactor. So I need to explain myself a lot about that. Same as case 16. The necessary conditions are this. They prevent transactional cost as a necessary condition. So all these are weird cases that need to explain. So we can decide to change, assuming we have this, the absence of that, what would it imply? So there will be a change. Let me explain this now. So assuming we said we negate the commercialization, what's the performance? So it kind of adjusts automatically, and we want to explain based on the analysis we've just been getting. So we can now change the conditions and see what's the behavior of biofuel attributes. As you realize, the consistency levels are set alongside, so we're able to determine the consistency levels. So we can be able to see the cases that are behaving well, and then also be able to assess the cases that, assuming we want to do negation of this, the behavior of case 30 is the most ideal. So we shall dig out why it is behaving well. Then if we want to deal with the digital ecosystem, what's their behavior? So we have a few cases on digital ecosystem and that are behaving well. So all these, the reasons will be the basis of our discussion of the results and our analysis of the analysis. So we can test both presence and absence. So I think that should suffice as an illustration to the rest. I think individuals can further analyze on their own and see. But ideally, once save the results, we'll just come to save or print. And to save the results as a test run, for instance, test run 11. 11th. Results. So we will find the results that side. So the basis of our discussion will now be in line with this model, the ultimate model. Either I want to take parsimonious model, which will be this, subject to this operators. Then we create more tables, Venn diagrams based on this. Mr. Chairman, I think if you don't mind, you'd permit me to end here the illustration of the operation of the QCA. But this is just a glimpse of what the data, the software could do. Thank you very much.
Okay, thank you so much, Bosco. I don't know whether Bosco is Prof on. I don't know whether Prof would like to add something. Okay, thank you so much, Bosco. This was really very, 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 very wonderful. I believe that the presentation has raised a lot of questions. And also given the fact that you have taken us through the theory, and today you have taken us through the practical bit of it. And honestly, I know that there are still some gray areas which people may want to ask, and I still keep requesting that. I remember I asked you that you could share with us the presentation so that people can keep on looking at it, reading it, and also trying it out. But I must say that this is really a very wonderful method for analyzing data, and also it helps us really to go deeper in some critical issues in comparison to other methods. But maybe before I invite people to ask questions, allow me to acknowledge again some of our colleagues who joined us. I want to acknowledge Dr. Goretti Chiune, and then Dr. Isaac Newton Kayongo. I think also Professor Muhammad Ngoma had also joined us. I don't know if they're still around. But thank you so much. And let me invite people to make some comments, ask questions, and I think we still have time to deal with all those issues before we eventually close this morning. So, any comment, you can raise up your hand. You can just unmute your mic and make a comment. Any comments, Livia? Hello. Okay, Bosco. What are the critical issues which somebody has to pay attention when you're especially using this software and also using the facet? What could be the critical issues, if you could, as we are waiting for other people to make the observations and ask questions?
Thank you so much, Professor. What is critical when applying this software is that we need to be careful not to set it against the operations of the statistical practice, correlational studies and regressional studies, because this theory has its own dimension and only seeks to integrate some practices from the regressional and correlational studies and then qualitative. So it integrates the two, and so we most of the time have to make our basis of analysis guided by the theory and literature. And it's critical to keep in touch with your theory and literature, because it's the foundation of the conditions that we establish even when we're getting to collect data. We will need to keep in touch with the theory, the conditions set out in the theoretical perspective or literature. And then once we test the data, the hypothesis therefore will be either confirmed or not, and based on the outcome of the data. Now, we also pay attention to the fact that the three assumptions give us different perspective: conjunctural causation, equifinality, and then symmetric causation. So we will also be careful to note that when we are running the tests, we run the tests for both negation and presence of the outcome. So we will be explaining the outcome variable in both perspectives and explaining the reasons why it is present and why it is not. And then the other point, Professor, would be we have to focus our minds on having to explain the counterfactuals if we need to go that direction, and not necessarily contradict with theory, but it may have to be improved on the theory or to add to the theory or to the literature. And once we've done that, then we are able to deliver robustness in the results. Maybe finally is that it's necessary to pay attention to the calibration of the data, because once you get that as erroneous, then the outcome will be quite misguiding. So calibration is essential. That is the center point of our analysis subsequently. And lastly, when we are discussing the results, we will discuss them on the basis of our objectives and hypotheses and in line with the theory and literature. Professor, those are the maybe the highlights I would consider quite critical to pay attention to.
Okay, thank you so much. Any other comment? Senior colleagues. Any other comment, any query? Of course, Bosco, I believe that through, even as people will be looking at, keep on reflecting on the fuzzy theory, the philosophy and methodology, there will be some critical areas which people really may need some insights, more insights, because this is a whole system, knowledge system, which helps us to analyze and also be able to make conclusions and basically. So I believe that you should be, I don't know, but I believe that through the week, many people might be able to raise some issues. And then maybe see that maybe can we focus on this area and see how to send them. But honestly, this is very critical for us for advancement of scholarship. And sometimes you find that the concept, like even self, the fuzzy aspect of like even when you talk about strongly agree, those ranking of level of agreement, you clearly, it's very difficult really so you'll find that this will really be able to help us to come up with the critical knowledge and advanced scholarship. But I wanted maybe senior colleagues to make one or two comments, and then we almost come to the close, because actually a lot has taken 3 weeks to have been focusing on the fuzzy theory, philosophy, and methodology. Dr. Goretti. Joseph Lasso, any comments?
Prof, I just want to sincerely thank my brother for the effort. This is it is new waters, and it looks very clean water to swim in. So I really want to thank you very much for ably bringing this out, and we hope by the time we are done with this, a number of us should be able to borrow some ideas and be able to delve into it. As of now, I really do not have any question for him, but rather thank him for ably bringing out the facility set theory. Thank you very much, Prof.
Okay, Ronald Mojo, some comment?
Thank you, Doctor, and thank you so much for Bosco presenting. He has given us a very good theoretical outlay of the fuzzy set theory. What I appreciated mostly was when he was able to mention the fact that also as you present these cases and you run the software, outliers emerge. And that forces you to revisit how you entered the data, or most importantly, also the fact that as it's giving you the output must be in line with the theory. You should not fight the theory. So that's one area I've really taken note of and I've appreciated with this presentation. Going forward, I think I may have to ask my colleagues to come together and we do a simple practical, maybe together as a team, to apply it, because sometimes, as Confucius says, when I see, I remember, but when I do it, I will never forget. So it's now pushed me to that point where I have to find at least some way or a particular situation to practice. I thank you, Doctor. I thank you, Professor.
Thank you so much, Ronald. I think we should come to the close of this session, because I see like the presentation, like I said, has really triggered a lot of thoughts. And I believe that, of course, learning is taking place, and the different perspectives, and especially I think what this presentation has really brought the critical aspect, which I also think that it's very difficult for you to deal with it without really, it must be aligned with the critical theory of fuzzy set. So all the analysis process must be strongly hinged in, and I kept on looking at Bosco highlighting the theories behind fuzzy set. So I want, as we come to the close of the session, I would really I want to invite Dr. Isaac Newton Kayongo will be able to make the closing remarks, but I don't know whether Dr. Ahmad does some comments you'd like to make before eventually we have Dr. Isaac close the session. Dr. Ahmad, any comments, and what do you think, how should we move? Because I really believe that this is very critical. I know there's a critical mass of students who especially those who are at proposal level, who could begin already seeing this as a method they could use for analyzing their data and be able to make critical. And also I believe that there are other colleagues, senior colleagues, who may want to further to really understand this and see a way of coming up with a paper and collect some data, analyze it, and really see. So I don't know, but I felt that maybe there could be some direction, and we could see how to move forward, because we have done the theory. We have also looked at the practice a bit, but of course, just going through once, and I may not really be able to help you go deeper. But of course, when I think everybody, when we get the slides and people keep on looking at them and also trying to download the software and trying to practice, like Ronald said, I believe that very critical direction will be taken. And the good thing, we have our own Bosco, and then of course our mentor, Professor Yusuf Ntai, will be able to take us really to the depth of all this, and really we have a critical mass of people who will be very thorough in fuzzy set theory philosophy and methodology. So maybe Dr. Ahmad, could you make some comments? Then we have eventually closing remarks by Dr. Isaac Newton. Dr. Ahmad. Okay, Dr. Isaac, please, you could close.
Okay, gentlemen, I would say good morning. I would like, first of all, to thank very, very much the organizers of this. I just imagine if they didn't do this, we would be far behind. I would like to express my appreciation and say that surely there's always a point to start learning, but learning will never end. Every time you learn something new. So, Mr. Bosco, thank you so much. I can say that everyone here has really benefited, but we will continue. Let us continue learning this, and I can see many more are coming. We are actually not the same the way we started 3 weeks ago. Something has been added. Thank you so much, and we'll keep on. Shall we pray? Loving Father in heaven, who is the giver of life and sustainer, we thank you so much. You are also the giver of intelligence and wisdom. Now we are continuing with the process of learning. We continue that you continue to bless us, that we learn more and be able so to impart to others, because that's the purpose of attending. You learn and impart to others the knowledge. We ask you, Lord, to dismiss us from this place. We also remember that some among us have lost the loved ones. Lord, be with them. We also appreciate that there are some of us who are also sick, others are bedridden. Lord, you are the life giver once again. We pray that you give them life, sustain them, bring them back to normal life. We pray, Lord, that you dismiss us from this place until we come next week. We pray in the humble name of Lord Jesus Christ. Amen.
Amen.
Amen. Thank you.